Hello, Mr. Hine. And we are today talking about a summary of what we've learned with linear equations because we're getting to the end of this. And I want you to be at a spot where you understand these equations from these four different perspectives. And that's kind of the goal of math is with every pattern, you can do it four different ways. You understand the equation, you understand how that looks in a table, you understand how that looks in a graph, and you understand how that looks in a tile pattern. And in fact, you're going to see this today, you should be able to move between all four ideas. So for example, if I give you the equation, you should be able to give me a tile pattern. If I give you the equation, you should be able to give me a table and the graph. If I give you the graph, you should be able to give me these three. If I give you the table, you should be able to give me these three. So the idea is, given one, you could figure out what that looks like in different scenarios. So here's an example of how it applies to all of them. So we have here, for all these, we're going to label the rate of change, which I will do in yellow, all of these, highlighter. Label the starting value, which I'll do in red for all of these, and I'll underline it. And then lastly, label the equation, which I'll stick with pencil for that. So given an equation, y equals 3x plus 2, remember that the rate of change is always before the x. And the starting value is let's just focus on the rate of change. So in the equation here, it's the rate of change is always the number before the x. So you can see here that this is saying that it's changing by 3. Where do you see that at on a table? Because these are all the same thing. These are all the same, right? Well, on a table, remember, it's how it's changing. So notice that when it goes from 2 to 5, it's plus 3, it's plus 3, it's plus 3. It's adding 3 for every 1. And there's your rate of change on a table. And now I do put the plus 1 because remember that 3, put this off over here, note, 3 is the same as 3 over 1. So we could have put 3 over 1 here. It's just 3 simplified. But that is these are the same thing. So there it is in a table. Where's the plus 3 on a graph? Well, that is how you're changing from point to point. So it's going up 3 from this point to this point. If I just focus on these two, it's going up 3, right 1. And notice that there's your rate of change on a graph, the plus 3 over 1. Right, that's the slope. I don't know if you see those arrows. There you go. And then on a tile pattern, those are the tiles it's adding. So notice it's going from 0, 1, 2. And from 0 to 1, it added these 3. From 1 to 2, it added these 3. So notice again that you're seeing that plus 3 again. Okay. So all the same thing with the rate of change. And the starting value is the number at the end. So that, again, is your starting value when x equals 0. So at figure 0, when we start, that's always what we start at. So in an equation, that's always the number by itself. So rate of change is the number before the x because it's changing x many times. This is by itself. In a table, notice that you can see it right there. There's the starting value of 0, 2 when x equals 0. On a graph, you see it on where's your point at on this line, which is right there. There's 2 on the graph. And where's it at in figure 0? Well, notice that there's 2 tiles to start. And that's how all 4 of these are related. So I hope that makes sense. And I hope, again, where you're thinking you should be at is if I give you a graph, can you get the equation and table? If I give you the table, can you give me the equation and graph? If I give you the equation, can you make a table and graph? You should be able to do all 4 of these, all 3 of these, just given one thing, because they are related. Hope that makes sense. Hope this doesn't feel too new to you, because again, it should be a nice summary of what we've been doing the last week. All right. Good luck on the assignment.